Okay, talking about the gases, right? Because our topic specifically is about gases. So, talking about this, as you have done the experiment, which is I gave you in our Google Classroom, so we'll be talking about those topic is all about the Boyle's Law. So, the Boyle's Law is the law of Robert Boyle, which he is talking about the relationship of the pressure and a volume. They're talking about this. I mean, he is talking about this. So when you say talk about pressure, pressure is defined as force per unit area. So that means pressure is equals to force over A, or which is the unit for force? It's Newton, or you can use here square meter squared, or any for area. That's it. Or kilometer squared or centimeter squared, that is for the unit of area. Okay. So pressure has an exert force, right? So talking also about volume, volume is defined as there is a three-dimensional talking, like for example you have a certain glass, you have this one and it have this one. So there are three, like for example this is in centimeter, 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 so it is expressed in cubic. So that means you can call it cubic centimeter. This is the cubic centimeter. So that is what we call volume, an area of a certain container. Okay, so he explained about the he explained about the volume and pressure relationship. So he explained that when a volume of gas decreases, the rate of which gas molecules collide with another and with a container increases. Thus, pressure shoots up. Conversely, when the volume increases, the collision rate decreases and the pressure drops. In other words, he explained that if you have higher pressure, you should have, or you will be having, lower volume. That means they are inversely proportional. Proportional with a constant temperature. The temperature here is constant. Take note of that. Constant temperature. Okay? So let's try to let's try to solve this. The given equations of Boyle's law according to its um, explanation. He expressed this one by pressure 1, volume 1 is equals to pressure 2, volume 2. Okay, during your experiment, since I already gave you the experiment, as you have observed, the marshmallow inside of syringe is when you pull it, what will happen to the marshmallow? The marshmallow will be having um what do you call this one, a small volume, right? But since you push it, it is indicate it's you apply pressure. So you apply pressure, it's higher pressure. So that means they are when you pull the syringe, I mean the what do you call this one, the something cup of a syringe, if you pull that one, the pressure is being lowered because you didn't apply any force to push. So the volume increases. So this is the equation of those. So like for example, you have a given pressure and you have a given volume, but you need to find the pressure too, and there's a given volume too. So you need also to derive the formula. Okay, and this time, since this is the formula, you need to divide them both sides. If what is you're looking for, you're looking for that density 2. So you put volume 2 here, both sides, then cancel out volume 2, and you're having this formula. That's the easiest thing about this. So that means pressure 2 is equals to volume 1 at pressure 1 times volume 1 divided by volume 2. So we can now solve the the problem. Okay, like for example, you have a problem of a sample gas occupies a volume of 145 ml at 560 torr and 8 at and 20 degrees Celsius. Calculate the new pressure of its volume is increased by 290 ml at the same temperature. So here, like I've said, the temperature is constant. So we'll put here the given. What is the given? Given is um, for volume, take note when you say volume, it could be expressed in ml. Volume 1 is 145. 145 ml. Volume 2 is 290 ml. Pressure 1 is 560 torr. So the pressure also can be expressed in torr, in atmospheric pressure, and it could be expressed in millimeters mercury, inches of mercury, pounds per inch, pascals, kilopascals, or bars. But here we're having torr. That means torr, it came from the Evangelista Torresel expressions. Okay. So pressure 2 is being asked. You put some question mark. So this time we can solve this. We can solve this one by using the formula that we derived. So P1 pressure 2 is equals to pressure 1 multiplied by volume 1 over volume 2. So substitute the formula, the given or the value. Volume pressure 1 is 560 torr multiplied by the volume 1 of 145 ml divided by what is the volume 2, 290 ml. So this time ml and ml will be cancelled out because it's divisions. So pressure 2 will be having 560 multiplied 145. 560 multiplied by 145, you got 81,200. So I put here 81,200 over 290 ml. 290 is already cancelled out. I mean the ml, sorry. So divided by 290, you'll be having 280. So 280 torr, since torr was left and that's not cancelled. So this is the unit. So it indicates that you have the correct answer because you have torr as a pressure, because torr is a unit for pressure. So you have 280. That is the Boyle's law. Okay, I hope you understand my discussions. Thank you for watching. Bye.